Hello, so today we are starting something kind of new. I say kind of new because you've done it before, it just looks different now. So it's called function operations, and today we're just going to be adding and subtracting different functions. So, what's a function? A function is a relation. I would write this down if you're watching. It's a relation in which each element of the domain X is paired with exactly one element of the range. Which is Y. That sounds like a lot of big words. X, Y, domain, range, relation, all words that we don't really like. So it's really not that hard to explain. I'm sure you've heard of the vertical line test. If not, this is what it means. Basically, it just means when you look at a graph, if you can draw a straight line and it only touches it once and it'll only touch it once forever, then it's a function. Because each x along here, this is the x-axis, this is where you find the domain. Each point along here only has one y. So I could go anywhere, draw a line, and it would only touch it once. Do you see what that means with the whole each x has exactly one y? Here's an example of what's not a function. So this circle, it's a circle. We think circles are shapes, circles should be functions. They have an equation that makes them on the graph, but actually, just do your vertical line test. This x point has two different y points. So it can't be a function. Hope that makes sense. It's the easiest way I can think of to explain it. So here we have two functions. We have a function called g of x and f of x. This is called function notation when it has that, it's like f parenthesis x parenthesis, that's called function notation. It's really just a fancy y. You guys are probably more used to seeing y equals x plus 1 or something from Algebra 1, but this is function notation. We're going to be working a lot with this, so get used to it. And we're just gonna be working on adding and subtracting these today. So, example 1, here's my g of x and here's my f of x. So, you see here we have f of x plus g of x. We're literally just gonna look up and see what's f of x and write that down. X squared plus 2, okay? And then we have a plus, so we're gonna put plus. This was our f of x. And now what's our g of x? 3x plus 1. Copy it down. Okay, now you already know what to do from here. This is what we just spent a whole week doing. Combine like terms, so x squared stays, 3x stays, and write it in standard form, sorry. And then the 2 and the 1 can combine. And that's our answer. X squared plus 3x plus 3 is f of x plus g of x. Okay, let's try f of x minus g of x. We have x squared plus 2 minus 3x plus 1. If you forget, what do we have to do first? We have to distribute the negative to the 3x and to the 1, so we'll have x squared plus 2 minus 3x minus 1. Now combine like terms again. X squared is by itself, This is minus 3x this time. And 2 minus 1 is just plus 1. So this is our answer for f of x minus g of x squared minus 3x plus 1. Okay. The next one is going to be super similar to this. It's just going to look a little bit different. So now we have this funky notation where the f plus g is in parentheses itself and the x is outside. Same over here. It's kind of scary looking, to be honest, but it's no different from what we just did before. You're literally still just adding f and g together, just like before. So we're going to write it exactly the same. We have f of x is 2x plus 1, and g of x is 5x plus 5, and they're being added, so the same as before. Combine like terms, 2x plus 5x is 7x, 1 plus 5 is 6, and that's my answer. Now we're going to do the same thing over here. We're going to start with 5x plus 5. That's our g. We have a minus f, 2x plus 1. And then 5x minus, or distribute the negative, sorry, getting ahead of myself. Minus 2x minus 1 is what that will change to. And then combine like terms, 5x minus 2x is 3x, 5 minus 1 is plus 4. So our answer is 3x plus 4. As always, if you have questions or you don't understand something, please email me. But we're gonna do one more example here. And this involves a little bit more than the other ones, but still not much. So now we have 2g of x plus 3k of x. So also, the letter doesn't really matter. I could change this k to an f if I wanted. The reason they're there is just to make sure you know that they're different from each other. Like g of x is not the same as k of x, and that's just kind of how they differentiate different functions. So here we have 2g of x's plus 3k of x's. So the only difference that we're going to do here is that we're going to be multiplying. So we have 2g of x, we're going to have 2. And then you're going to copy down g of x just like before. And then we have plus 3k of x. What's k of x? 5x squared minus 3. Copy it down just like before. So now, before we add anything, we have to distribute the 2 and the 3 through. So we're going to do 2 times 3 of x and 2 times negative 9. So we have 6x minus 18 plus 3 times 5x squared is 15x squared. 3 times negative 3 is negative 9. And now we can go ahead and combine like terms. So 15x squared should go first, because it's the highest exponent. And then there's no other, just regular x, so we just add 6x. And then negative 18 plus negative 9 is just negative 27. And that's our answer. So go ahead and start on your homework. We're going to do just a few practice problems of these, and you should be done.